We got like this 4 billion parameter model. We were really excited, but it was like worse than like a 30 million parameter model.
Everyone who trained a model has war stories. We asked top researchers to share theirs.
My name's William Chen. I am a third-year PhD student at Carnegie Mellon. I work on speech processing.
I'd love to hear a few sentences about your project and what you're working on.
We asked the question of what happens if you train a really big ASR model. So traditionally, ASR models are pretty small because people want to put them on devices. A lot of the scaling work has been in LLMs. So we asked the same question, what happens if you make ASR models really large? What do they learn? What do you get out of it?
And could you recall a model training moment that didn't go as planned?
Yeah, I can recall very many. So at the start, we actually had some pretty big issues of getting like the bigger models to train even. A lot of it is due to like more implementation things. Our gradient sharding was like not correct, where some things were like downcast like the precision that they shouldn't be. So what happened was we got like this 4 billion parameter model that we thought would have been really good. We were really excited, but it was like worse than like a 30 million parameter model that we trained earlier.
And what was the very first anomaly that told you something was off?
A model that we thought would be, less than like 10 word error rate, it was getting like 20 or 30. And like that 20-30 word error rate is like a pretty easy target to hit. That was something people were able to do like 10 years ago, 15 years ago. So we were pretty surprised at that.
And roughly how much compute or wall clock time do you think it burned until you caught it?
I think we probably wasted like 2 to 3 weeks of training. First, like the big training run that failed, then like another week or so trying to debug it. I think we're training on like 32 H100s at the time. So whatever 32 H100s times 3 weeks is, yeah.
And what did the final fix end up looking like?
So the final fix was like we just like completely changed like the underlying code of how we were doing some of like the model optimizing or sharding. We swapped the deep speed from like a more in-house implementation that was working for us before, but we never really scaled. So we swapped to that just because like standard industry practice to use deep speed, and then it worked, yeah.
What specifically are you especially keeping an eye on, be it the metric or anything else during the training process?
So during training, we log like the token prediction accuracy, and then we also look at like the token error rate, which is like, it's not perfect, but it gives us an idea of what the final model is, because ultimately ASR, word error rate, is like a very simple metric to evaluate. So we have a pretty good idea of how good the model is during training too.